Okay, so the next one here, test 7.1 F class 9 maths. Will be one question only, but it's a little bit of a long question. Okay, listen carefully. B8, page 131 on your textbook. Open to that page. Let me read the question for us. In a right triangle ABC. Okay, there is a diagram given. So let's just draw that. So here is a diagram. Something like this is given. And this is D, B, C, A, and here M. So given to us here, let us write down. In right triangle ABC, right triangle ABC, right angled at C, comma, M, so point M is the midpoint of hypotenuse AB, of the hypotenuse AB. So M is the midpoint of this AB. Hypotenuse means this length, AM equal to BM. So we may as well write here, and the meaning of this one is that is AM equal to BM. We can write ourselves like that. Then C is joined to M. Continuing, C is joined to M. C is joined to M and produced. Okay, produced means made longer on the same straight line. Produced to a point D such that dm equal to cm. The line dm equal to cm, that's given. Stop. Point D is finally joined to B, so we can write there point D is joined to point B. So that is given to us. So sure, that means proof. So to prove here, several things are here. One is triangle AMC congruent to triangle PMD. Second thing we need to prove is angle DBC is a right angle. That's what we have to prove. Number 3 is triangle DBC is congruent to triangle ACB. The fourth one we need to prove is CM equal to half of AB. Let's see how we'll go about that. Okay, so here one by one we can start. Proof means our answer. Okay, we can just start with one maybe. So take these two triangles, in triangles AMC and triangle BMD. Okay, since we have put plural here S, so just write BMD is enough. So in these two triangles, slowly let's go. AMC, BMD. AM here, the first two letters, as you can see here, equal to the first two letter BM or not. Let us check. I think they are equal here because it's given AM equal to BM. So we write there. The reason is given in the question itself, right? Then next one, CM, third and second, and DM are equal or not. Let us check. I think they are equal here. CM equal to DM. So right here, same reason again given in the question itself. Now let us find out the angle between these two sides, AM and CM of this triangle AMC. AM and CM, between that here 1, so angle 1 is the one, and between this BM and DM belonging to the two sides belonging to triangle BMD, BM and DM, this angle is between those two sides, so there is 2, let us mark. Are these two angles equal? The answer is yes, because we know these are vertically opposite angles, as you can clearly see here, 2 lines crossing, and the angles in these two marked angles are called vertically, and they are like that in that kind of a situation or pattern, you can say. So if in two triangles, two sides and the angle between those two sides of the first triangle are correspondingly equal to two sides and the angle between those two sides of the second triangle, then we know earlier we have learned from the congruency condition for triangles that those two triangles will become congruent to each other by a condition called SAS congruency, right? So we may as well just keep this one as equation number 1 and write here, therefore triangle AMC congruent to triangle BMD. You may write once more, and you can say, since using just now equation 1 repetition. First answer. I kept here 1 because we are going to need it for proving the next things there. So let us just continue here. Now this part is okay, I think, now, so let's wrap it out and continue. Here, see, number 2, let us try the proof 2. In order to prove 2, let us do like this. Since triangle AMC just now proved congruence of triangle BMD, as we can see by using equation number 1, as you can see here, AMC triangle congruent to BMD proved. Therefore, the corresponding angles will be equal. So A here, this angle A will be equal to first letter here, first letter B. At the point, there are two angles, so we have to specify in this triangle here DBM. So we write here angle DBM. This second first letter is between, so first letter, angle B means DBM, because we know CPCT, corresponding angles of congruent triangles, are equal. Now these are nothing but which are also alternate angles. When you consider these two lines DB and AC, then these two lines, then this angle here inside, angle here and here, see, equal means they are alternate. And we know that from our previous chapter, lines that and angles, that if alternate angles are equal, then the lines above and below are parallel. So we write here, therefore DB is parallel to AC. Now if two lines are parallel, then we know, and consider this transversal, this one, something like this, B, C, here D, here A. So if these two lines are parallel, DB, AC, these two angles inside on the same side of the transversal BC are called co-interior angles. So that one, let's just mark 3, sorry, wait, DBC angle, DBC plus here ACB equal to 180 degree, because we know that if two lines are parallel, from our previous chapters we know that when two lines are parallel, the sum of the co-interior angles become equal to 180 degree. So that is thing. So here that implies angle DBC plus SCB given in the question there in right triangle ABC, right angle that C means this, in this triangle C is right angle means this is 90, so just write here 90 degree equal to 180 degree. Okay, give the reason for this, because angle SCB is already equal to 90 degree, comma, given in the question, or semicolon also you can prove. So in that way, here we're going to get here, okay, let's just write this one, triangle AMC congruent to triangle BMD. This one is equation number 1, and then just give this space maybe. So here, from here, I'm coming from here, so angle DBC will be equal to 180 degree minus 90 degree, so which is equal to 90 degree. 180 minus 90 plus 90 shifted to the right side, so that is, in other words, number 2 here. We're doing number 2, right? DBC, this angle 90 degree means angle DBC is a right angle. Proved. So that's your answer, number 2. Let's go to the third one and then prove that one. DBC triangle congruent to triangle SCB. Number 3, let's do slowly. In triangles DBC and SCB, let us take those two triangles. These two triangles, DBC and SCB. I will write here. Okay, before this, just wait 1 minute. Let's just prove here. Again, since triangle AMC is congruent to triangle BMD, as you can already proved in 1, using equation number 1 here. This one, sorry. So this line here is C. So first and third letter, first and third BD, because of CPCT. Let us just keep it later. This one, equation number 2. Now take those two triangles now. So in triangles DBC and SCB, these two triangles DBC and SCB, DB first two letters equal to first two letter SC. Just now we got from equation 2. We've proved that in equation 2 just a moment ago. See, SC equal to DB. Then here this side here BC, second and third, is equal to second and third. DBC SCB, DBC SCB. Okay, so second and third, BC and CB. CB or BC, same thing, since they are common. This side is common to both the triangle. BC belongs to DBC, CB or BC belongs to SCB. Then let us find the angle between these two, DB and BC. The DB and BC is this DBC, angle DBC, which you have already proved is 90. Then between this SC and CB, SC and CB, SCB, that is already 90 in the given. So DBC 90 here proved, SCB 90 degree given in the question. So both are equal 90 degree means, since each being 90 degrees each, since each being 90 degree. So we have that. Now we know here C. Between this DB and side BC of triangle DBC, angle DBC is there, DBC. Two sides and the angle between those two sides of the first triangle are correspondingly equal to two sides and the angle between those two sides of the second triangle. Then those two triangles are congruent. Triangle DBC congruent to triangle SCB by a congruency condition. Let's go from here. Call since using SAS congruency condition. So these two triangles are congruent, therefore. So that is proved now. Finally, CM equal to half AB. CM. Okay, so let us just put this one as equation number 3 and write once more. Therefore, triangle DBC congruent to triangle SCB since using equation number 3. So we got that. That's your answer. Now let us write once more. Since triangle DBC congruent to triangle SCB since using equation number 3, as you can see here. Wait, see here. Yes, since using equation number 3, this is equation number 3, DBC SCB. Okay, this is 1. So therefore I will write here this part here, DC, first and third letter, is equal to first and third letter AB because of CPCT. We're going to use that to prove this third one, CM equal to half AB. So CM, so these two are equal. Now I will write here that implies DC here. DC is DM plus CM. So DM plus CM equal to AB. Just breaking up this DC into DM plus CM. That's common sense, right? So once we're through with that, let's come here. Or coming from here, that gives you, we don't need DM, so try to evaluate that. Now I will write here CM plus CM equal to AB, and I'll give the reason. Since we know CM equal to DM, semicolon, given. You check the question there in the beginning part of what you've written, CM equal to DM given in the question, right? So since CM and DM are equal, I can replace this DM by the CM. So it gives you twice CM equal to AB. CM plus CM twice CM. So CM will be therefore equal to, no number here means 1 is there, 1 by 2 into this 2 will come down. So the third one is proved, fourth one is proved, right? So here, here this is number 4. Just write your 4. Trying to prove this 4. So to complete this 4 points, 1, 2, 3, 4. So it's a little bit long but not hard. Just go patiently, listen carefully, you'll understand. Okay.